Welcome to the channel, guys, and this short episode, hopefully short, on calculating and evaluating state matrices using a transition matrix. So we're going to use the recurrence relation to determine S1, S2, and S3. So that should look like, firstly, that a S1 is going to be found by taking S0 and S0 is equal to T by Sn. So here we'll take T and we'll times that by Sn because we're starting with 0, Sn is S0, and that is going to mean that we get S1 is equal to whatever our response there is, or our answer there is, so 0 plus 1. Then we use this one to find the second and the third, and so on. All right, so over here, I've already put in my two matrices into my CAS. So I'm going to put down S, and I'm going to have that there. That'll save it. Now I can use T and times my answer. So let's find the answer button. Hiding down here, T times S. So you can see there, I've got T times the answer. And I'm just going to hit that 2 more times to find, that's S1. I'm going to hit my execute button twice more to find S2 and S3. There we go. So from that point of view, I've got S1, S2, and S3. So over here now, I can start to put these in line. So S1 is 180, 130, and 290. Then question 2, S2 is equal to 207, 136, and 257. And then last part of this question, number 3, S3 is equal to 225, 132.1, and 242.9. Okay, so that's that first bit done. Then use a relationship, which is our rule here. Use a relationship to determine S2, S3, and S7. So what all this is going to ask us to do is verify that if we use the rule or the recurrence relation, the two outcomes are the same. So we scroll down here. So we want to put in S2 is going to be equal to C2 times S0. Okay, if you want to write this out in full, you should actually state the transition value there and the S0 value. For the sake of time, I'm going to leave it like that. So now we've got T to the power of 2 times S, because that's my initial state matrix. And you can see there that my answer is 207, 136, and 257. Okay, now we can see that this answer here is exactly this answer here. Okay, and if we follow that through for S2, S3, etc., S3 is going to end up the same. I'm just going to jump to S7 because I think determining that now is going. Okay, so let's just jump to S7. 10. S7 is equal to, again, same deal, t to the power of 7 times S0. Go and punch that in. T to the power of 7 times S. And there's our 7th state. 244.9 and 129.7, and then 225.4. Okay, so that's those ones done. Follow the same procedure for S3. Now it's asking us to calculate 10, 15, 17, 18 to show that to prove. So what we're doing is we're proving. So what we're going to do is firstly calculate that, but then prove that that's right to one decimal place. We have these values. Okay, so let's write them down here for C. The value n equals 10, n equals 15, n equals 17, and n equals 18. Okay. Okay, so small pause in operations there, but I'm back now. So we're going to substitute n into our rule equation. So once again, that's okay. So remember that we're looking for Sn is equal to transistor matrix to the power of n times SO. Pop over here and plug them all in. So the first one is 10, so we want t to the power of 10 times S, and that results that. So I'm going to write it to the first decimal place because that's what our answer is asking for. And we get 246.7, 129.5, and 223.9. Okay, so already you can see rounded. It's already rounding to that. And we'll continue there. So let's go in, change our 10 for a 15. And it's just going to get closer and closer to those results. Sorry, the only one that hasn't rounded there. Sorry, they're close but not rounded. I don't know what I was looking at there. So we're getting close. Next one, we get even closer. So 247.0, 129.4, 223.5. Okay, so the bottom one's there. The second bottom one's there as well. And we're getting closer to the top one, the top element. So if you look at that in terms of how we're going, the closest we get is we're not there for any of them there. Then we're there for the bottom two. Now let's go plug in 17. Change my color back. And we've got 247.1 now that we've rounded that, 129.4 and 223.5. Okay, so this time we've got all of them rounding to that. So now we've hit the steady state, and now we need to prove the steady state. We need two examples in one, two consecutive examples that round to the same value. So we want to get that for the 18th as well. So 247.1 again, 129.4 and 223.5. 0.5. So why are we happy with that being the steady state? We're happy with the steady state because the n values, consecutive n values, so n is equal to 17 and n is equal to 18, consecutive, one after the other, both produce a state matrix that rounds to the first decimal place and has the same value. So from here on in, from 17 and 18 up, we're going to get the same values to one decimal place each time. Okay, so that is us proving or showing that the steady state matrix is 247.1, 129.4, 223.5. Okay. Hopefully that helps out, and we will see you next time. Give the channel a like, subscribe, etc. if you want the new videos as they come out, and we hope everything is going well. Cheers, gang.